Hey everybody, thanks for tuning in. I'm David from Lit Protocol and absolutely delighted to be joined by Dave from Osmosis today. Dave, thanks for being here.
Thanks. Great, rare opportunity to get a podcast of just Dave's.
Terrific. Yes, those in Dave Dow, I hope are tuning in for the folks that are clued into that. Um, well, yeah, as we get started, do you want to say a little bit about what you do, maybe how you got into crypto and what you're focused on now?
Yeah. So what do I do now? I work on Osmosis and another product, Polaris. What these are is we're building a exchange that's kind of one-stop shop, so you trade all assets, all tokens privately. So we try to solve the complexity of having many wallets, where now it's easy to move back and forth across them, track what you're doing. We can get all of your assets private, and if you want to move funds from, let's say, Solana to Hyperliquid or Arbitrum to Osmosis, make it extremely easy to do all these with swapping actions, etc.
Amazing. We'll get into that and into MPC autopilot and your use of Lit
Mm-hmm.
protocol here. But how long have you been in crypto? How did you first when did you first buy a coin or a token?
Uh, Buying coins actually oddly late, but I've been involved for I think 9 years now. Oh, base back in high school, I fell in love with cryptography, and that's 9 years ago. And I hear these cryptocurrencies. Okay, well, involves cryptography stuff. Let's see what's going on. And fall into the weeds of it. Like, love it. Distributed systems like BFT, it's fascinating. Learn with the CK snarks and the idea we can use these to achieve anonymity. Yeah, this is this is so exciting. I go to college, join the blockchain at Berkeley Club, where we have a bunch of people who are super passionate about this. I then go work at Tendermint to help design Cloud's SDK and Tendermint, most battle tested BFT system. And I stay involved with that for many years. And then I go do research at, at Berkeley with a professor on zero knowledge snarks. Figure out how to optimize these, etc. And then this keeps snowballing into where we are today.
Awesome. Um, and can you give us a little bit of history around how Osmosis started working on Polaris?
Yeah.
What did that look like? What's the backstory there?
Okay. So essentially we realized for osmosis, we need to make this go cross-chain. There's not really a world that's short term where
Okay.
osmosis
Sorry
to
to interrupt
blockchain.
you. Maybe you can just define what osmosis is for folks
Oh,
as well. Yeah.
yeah. So osmosis uh, is a Cosmos chain that's centered around trying to become the best interchain DEX. So this means that it's the best spot to go trade any assets independent of what chain they start. So, and then it also competes on offering the best UX, like at UI layer, by trying to do things to make fees not a thing you worry about, uh, eliminating the need for like thinking about bridges, eliminating a lot of latencies of stuff we deal with, eliminating the wall entirely by being self custody, doing smart accounts, and so yeah, this is what it aims to do, and now privacy as well, as this is key frontier.
Amazing. And so you're like, okay, cool. There's a lot of VMs that we can't support.
Yeah,
We need an interface for that, and then presumably that's kind of how Polaris as a
yeah,
project emerged out of this.
exactly. Where it's a lot of VMs, and there's this problem where liquidity for an asset is going to be sticky to the chain it starts on. Where, like, let's take a new pumped up fund coin. Okay, someone wants to trade this. The best exchange that's decentralized should let you trade it. Why wouldn't it? The user wants it, so one UI can offer it. But okay, it's just launch a pumped up fund. How is it in the world just to be liquidity for that on another blockchain? It's a bridge away, etc. It's not going to be, the other blockchain is not going to be the best liquidity venue. So how do we solve this? Okay, let's go build an architecture that gets this lets you basically dispatch the swap to another chain. Okay? And that's kind of the start of Polaris. So okay, we can use this to start uh get we can start building a stack to start letting you go from Osmosis to swap chains and get assets back. And then we use extending that as we go down this, we realize, okay, well, hey, the other big problem we have is wallets. These wallets suck. Where in the sense that you don't want a different wallet in Solana, a different wallet in Cosmos. You want this to feel unified, and ideally not even have an extension. Well, what's our option to get rid of the extension securely? Okay, you have smart accounts, but this is kind of hard to get working across chains. We can make a fairly complex architecture to have this like have things on a Solana chain, kind of query another chain. But this is so it's very complicated. Like SVM contracts and client proofs. This looks actually a little bit like what the thing we designed within Cosmos called interchain accounts. You can do things to like shave down the complexity of that still, but there's problems here. One of the big ones is latency. So what's a way to fix this? Turns out MPC is an incredibly clever trick where if you bridge your tokens to Osmosis, uh, then with the light client bridge, this means that you trust this validator set this to basically do actions correctly, and then if they maliciously collude, which we think is very hard to stake assumption, they could then steal funds. This has never happened before in kind of the entire history of proof of stake. There was risk of this exactly once, as far as I'm aware, which was the Terra explosion, because Terra had a runaway mint on top of stake. Uh, there's never really been a risk. So okay, that's what can we do if we're in this worldview then? We have a proof of stake chain that the users trust. Well, hey, then it's somewhat the same security model for this this proof of stake committee, this validator set, to have a MPC key on your behalf on another chain. So now this MPC committee can now enforce consistent actions or consistent properties like smart account rules throughout. But actually, if you have this committee you trust, well, there's a lot of ways to authenticate to a committee. Like we could do these we can do OAuth things. We could have more traditional like Web2 security models, but instead of a single backend, it's this committee because the committee can have secrets. A blockchain is a different model. I won't say a blockchain can't have secrets. It's more complicated than that, but it's not the same as like how do you create an OAuth challenge or the OAuth state. That's a different story, which a committee, an NPC committee, can do. Okay, so great. We can start having like more regular logins for people and okay, we can also have this committee handle a lot of complexity for you as the user. We can have this committee do things like the shielded wallet sync. Uh, so this can solve a lot of the problems of a shielded wallets without making you as a user like kind of lose out. So this is a really fascinating thing of wow, we could use this to extend your proof of stake assumptions to giving you privacy and access to all chains. And this is kind of the evolution of ideas that led to
Makes a ton
Polaris.
of sense. I mean, there's
Yeah.
totally this light bulb moment as soon as you kind of like look at the world through a programmable account.
Mm-hmm.
It's no longer kind of a chain centric world, and so
Yeah.
we've worked together, and you all have developed this what you're calling excuse me, MPC autopilot. We're
Mm-hmm.
using some of the programmable signing with Lit to power that. How did that come about? How did you first come across Lit and yeah, decide that it was the right solution for you?
Yeah. Honestly, I don't even know how we first came across Slit. I feel Sunny just knew
Yeah,
about
I,
it.
I hung out with Sunny at ETH Denver several years ago. Yeah.
uh, Sunny tells me about it. Like, whoa, sounds incredible. Okay, we have these folks running FFC committees where they have two things: threshold encryption and TSS signing. they have it built such that every member of the committee runs in a TE. Okay, perfect. So now the committee's large. There's, as far as I'm aware, never been a multi-sig compromise of more than four entities. Great. This one needs, we set the threshold. We can set it to like minimum six, minimum seven. And and they're all TE constrained. TEs that are in a data center, not just TEs they hold themselves. Very big difference.
Hmm.
And so, okay, what's an attack model? Okay, you'd have to go break into seven data centers, have these don't affect guys with guns. Have and then basically break into the TE of each independently with no errors. This is quite hard.
And then, as I'm sure you know, lit does a key refresh every hour, so you have to do that in the confines simultaneously within a 60-minute window.
Oh, true.
Yes.
Even better than this, right? So this would be insane. I think this is like too hard for even nation state actors. And so now, great. This is actually a really solid base to do a lot of things. You can't trust just a TE for a lot of things. We see this even single TE in data center. I think is too big. Permissionless TE, we see attacks all the time. The one from I think last week was insane. Of just Intel doesn't actually even encrypt the RAM properly in the SGX. But other ones are better than that. But in a single data center, okay, maybe there's a data center breach and someone does they bypass the guy with the gun. Uh, Google. I'm blanking on the name of it, but there was a whole NSA or FBI thing of Google used to have one when you everything inside of Google is encrypted. All user communication to the Google entry points encrypted. They used to have this machine for passing the entry point to the internal system, where the data was unencrypted. I forget which U.S. agency, NSA or FBI, broke in, tapped those wires, got all data in and out of Google decrypted. This was. Uh, I'm blanking on when this was also caught. I think it
We'll
was
see
a
if we
snowden
can put it in the
case.
show notes. No, no worries.
Yeah,
Yeah.
uh, but so the data center break-ins, but not cross entities, cross countries simultaneously, very different. And here it's not. You can't just tap a wire. You have to really intrusively break in and kind of break into the hardware in a way it's still usable. Feels better than like.
It's a little bit of a tangent, but I find it personally incredibly fascinating the timeline between the Snowden revelations and when the cloud operators started offering TEs as a service. I've got to imagine there was some pretty angry phone calls where, like, major financial institutions were like, "What? You're sending all of our customer data to a consortium of world governments? That cannot stand." And then the cloud providers go to the hardware providers and be like, "Hey, we've got a major problem on our hands." So it was about 24 to 30 months after the Snowden revelations where the TEEs started getting offered at the cloud providers. So this was my own kind of like personal speculation on the time frame there.
That's shockingly quick.
Yeah.
Wow.
I mean, the technology around secure hardware is decades old, right? But in terms of like it's time. We got to get this to production. That's a major why now for sure. Again, who knows what actually happened there? But anyway, okay, cool. So now that you kind of are like operating from this model of being able to inscribe the way that key material is going to sign across multiple chains, how has that changed the way that you think about building what's next and
Mhm.
operating the system?
Yeah. So first, it's kind of changed what my model of kind of blockchains are, where before we used to think of it as like this one synchronous execution environment, but now I really think of it as like, okay, the Valor set is this kind of MPC committee that can act on your behalf, and then kind of execute things anywhere. They can have internal synchrony, like across chains even. So now, as a user, I think of this as we've uh, we've we now have systems where you don't first of all blockchains many blockchains have different key materials. Okay, that's solved. You have a mnemonic, or you have some you know some root of trust that can be derived from mnemonic. So it's below down. and then the committee can derive a separate private key for each chain on your behalf. Great. Um, then, so we now don't have to worry about elliptic curves as a problem. Like,
Right.
there's one user can have curves anything. Uh, Notably, very big deal for privacy things, where it's always a different curve because they tend to have a well, uh, it's always different curves than your normal curves, like or rather the Sec 256 curve. Mhm. So that's one big problem solved. Another one is smart accounts of okay, before all smart accounts have to be written in first there was single chain, and then they'd have to have some complicated on-chain logic. Great. Actually, your committee can you can program this all for your committee to do, and this can be in any language. You write it once, it can be enforced everywhere. Something I care very deeply about is rate limits, and the I just think that anyone designing any system should have an answer to if there's a bug, why did the user not lose everything? Almost all of DeFi fails this test. Almost every bridge fails this test. It's kind of ridiculous. You one really basic answer that's actually great. Let's do a couple of these now. You have a pretty secure system. Is okay. We're gonna have a rate limit of at the end before any action go through. We say how much money is left this account. Is it more than 10% in the last day, or is it more than $1,000 a day? Okay, needs additional authorization,
Yep.
or it's blocked.
Yep.
And that's such a huge protection. Any software bug, you get less funds. Yeah, less funds getting stolen.
And like one of the
Um,
things, this notion of checkpointing, I don't think we've seen any wallets implement this yet, but I've chatted with a couple about around, if you've got a mobile app and the wallet, and there's open questions on like the verifiability of the data and whatnot, but if the user is consenting to give the GPS location uh, to the application, you can also imagine like user focused checks. It's like, okay, wait, you're trying to withdraw the entirety of your balance. It's 3 a.m. and we can see that you're at a casino. Like, maybe your wallet is smart enough to actually act as a guardrail, and that's like a playful case. But a more serious case is a wrench attack, right? You like
yeah,
travel to a new city. There's a physical threat. Right now, there's like no protection from something like that.
yeah,
Granted, it's a different model than the software bug model you mentioned, but kind of the same solution.
yeah. I actually never considered this. In some sense, an NPC company has a proof of location ability. You can choose. Yeah, you can choose what you don't want to do with that. Do you take advantage of it so you don't care if they know your location, or do you VPN it so then they don't get any information? It's kind of user choice. Oh, that's actually pretty clever. I've never thought about location safety.
Yeah, pretty fun stuff. I mean, there's just like so much that starts to become possible. You could imagine your crypto wallet being aware of your fiat balances and all of this
Mhm.
kind of thing. Um,
What
Super cool.
one
Oh, go ahead.
one other thing you get is your NPC committee. It's can also do use can kind of have trust itself for facilitating faster cross-chain moves. Like, let's say you have money on Bitcoin, the Bitcoin chain. You want to move Bitcoin and Bitcoin to any other bridge or any other chain. Every bridge that's decentralized still has a Bitcoin finality period, or at minimum, actually, let's go even easier than that. They'll at least wait for your transaction to get into a Bitcoin block because there's no pre-conf. Okay, so average time between signing a transaction to get into a block uh, or is 10 minutes at best because proof of works minutes. Okay, so how do we beat a 10-minute latency? Well, let's say I want to move $10,000 from Bitcoin to anywhere else. I don't. If the MPC committee is going to sign this, what if there's another actor on, let's say I'm moving my Bitcoin from Bitcoin chain to Osmosis. What if there's an actor on Osmosis who says that, hey, I'm willing to trust that the committee told me they're going to move it, they'll move it, and if they violate this, they'll get slashed, e.g., proof of stake. Um, because I'll front these funds immediately. Typically, so there's these solver networks on almost all chains now. These all block on funds kind of at least the initial user transaction landing on chain or some pre-comp of this.
Right.
But you don't even here to go from chain A to chain B with this committee or with a committee's one strategy. You can eliminate the latency uh, of the source chain entirely. Like user authenticates the committee talks to a solver. The solver will give you user funds on chain B, and there's no chain A latency involved because the solver just knows that it'll eventually get chain A and therefore eventually get bridged to them. And
Yeah.
if this doesn't eventually happen, slash it.
Yep. And yeah, like I guess the assumption there is that the coins are locked in some way, like a resource lock
Mhm.
has already occurred on chain A by the time that like intent goes up.
Yeah.
Super
Well,
interesting.
we don't need a resource lock in on chain because if we trust the committee,
I see.
it's kind of because if their committee is the one who's issuing these locks or moving the funds, like then it's they've given you the guarantee off chain or let's say on osmosis the chain. And you trust this so you can look at it.
That's super cool. That totally makes sense. Yeah, your model is that like something like MPC autopilot is
Mhm.
the only party managing the key material in this case.
Exactly.
Yes.
You could technically achieve the same thing if there's a self-custodied TE on the user's behalf. Which one day if we get TEs and phones, that'd be quite cool. Uh, but this is still
Yeah, I mean,
kind of inside.
it definitely like it definitely starts to feel like in a chain abstracted world, this idea that people have been saying for 10 years, which is like eventually the blockchain goes into the background. We're really starting
Yeah.
to see what that world looks like. And Polaris so far, and I know things are still being iterated on rapidly, and it's like super amazing to see how fast the
Mhm.
progress has been. And so as you kind of think about the next, call it 12 to 16 months, either in Polaris in general or how you intend to use Lit protocol in it,
Mhm.
what's exciting to you in the kind of midterm
Yeah.
future ahead?
So honestly, the biggest thing for me is delivering on privacy. Like when we initially announced Osmosis, we had two premises: solve MEV, solve like privacy. I feel like I wake up every day so excited that like I'm now spending on solving privacy. Where right now what we're doing is right for this call, I was basically working out just final things of authentication methods with Lit to give you a shielded for how to do shielded wallets. Use this MFC committee, and in a way it feels seamless. We have something where I authenticate with my existing like Kepler wallet, and that's now working for doing private swaps with funds resting on Nevada on Osmosis going back single transaction seamlessly using Lit as both how we custody and how we do the funds and movement. But there's no and how I view the next 16 months going, basically, or what I'm most excited about is getting to privacy of all funds. You can now kind of you don't think about chains anywhere. Just think about hey, it's like I want to earn yield somehow. I want to swap token somehow, or I want to go deposit into an app, or open up a leverage position. These all just happen anonymously,
Mhm.
and we don't just stay at anonymity of actions, but we also can start hiding. We start maybe in a year plus time we start getting protocols to no longer reveal all individual positions or individual user actions. Only some we start revealing only aggregates. And this is another big usage of NPC, and which also makes me excited about Lit, which is let's say a lending market. I want to borrow $1,000 with $2,000 BTC collateral. So if Bitcoin drops 50%, I must get liquidated. Let's say Bitcoin right now is 120K. Well, okay, so the entire world can see there's liquidation position at Bitcoin 60K. So then you can have situations where people will try to like snipe the price to hit 60K. Your lending markets work backwards, start saying, okay, we're gonna not make liquidation 60, we'll make it like 70K ish, and based on a TWAP, and hope things work out. But these get but instead we could we could also just hide the fact that anyone knew that you did something at 60K. What does the world really need? I think the world really needs some aggregate information and to make the market correctly that, hey, there's so much, let's say there's maybe $1 million of Bitcoin that will be liquidated if Bitcoin it's somewhere in this price range of, let's say, Bitcoin 60 to 70K. They don't know you did something at 60K. They just know that's something in this price range, which gives you, uh, which okay, the market can use this to know how much leverage is built up. That's actually a pretty important property. But this doesn't de-anonymize your action because when you unwind it, you also have to show like some subtraction, and that could link that hey, you're the same borrower initially. Like even if you made the borrower's address like a Z address, a shielded address, you could still link the entry and exit. Whereas now we start getting wider and wider anonymity sets for decorrelating your actions. So I start seeing, yeah, seeing us redesigning all markets and other on-chain infrastructure.
Yeah, it's super powerful. And let me see if I can confirm my mental model with Z wallets. Like people use the term agent a lot in light of LLMs, but in many ways, this Z wallet is your agent in like kind of a classical sense that it's out there performing interactions for you, but the fact that you're the controller of it is obfuscated from the public.
Mm-hmm. This is the goal. The goal is like people, all the rest of the public should know is that someone in the world did this. Like, let's say there's right now there's okay, actually, I'm content to remember the exact amount of sec in the Zcash pool, but let's say it's 100 million sec. No, it's from price point. Okay, 100,000 sec in the pool. Well, then if someone does a shielded to public payment, uh, the rest of the world should only get to know that it's someone in the pool. They have no idea who it was. And that's kind of the goal. Let's make that true of every action. For almost everything you do on chain, let's make this as anonymous as makes sense. Right? Because if there's only 10 people using app, okay, there's no hope. You're one of the 10 people in the past just use that. But hey, at least let's get you as hidden as though there's 10 people. Let's make you one of the 10, not exactly this address. And we can solve this for things that don't. We're on a. I think very soon we're getting to the point where this is anonymized for swaps, lending, and holding, but then and sends. But now we can start parlaying this into more and more DeFi.
Here we go. It's happening.
Yeah, it's
Um,
happening.
yeah. Okay. This is phenomenal. And so, what's the best way for people to, yeah, try out Polaris, follow along with what Osmosis is up to?
Yeah. So you can try out Polaris at beta.polaris app. It's still in beta as we're trying to get privacy rolled out soon. You can stay tuned by following us at Osmosis Zone and at Polaris app on Twitter. Or and then yeah, just follow along. Please try this out and engage.
Private, fully chain abstracted finance. If there ever was a North Star. Yeah.
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 uh, Thanks so much. That's been huge for all of this. Like, uh, working through all like being able to use this for solving a lot of these transaction custody things. How do we? I didn't talk about much today, but like, how do we do these swaps in a way it's non-custodial? That's thanks to Genius
Yeah, if you
Flip.
want to take a moment to share that, I think the folks tuning in
Yeah.
would love to hear.
So we have another system we call like NPC runners, where let's say I have funds on Solana, and I want to go buy something on let's say I want to buy BTC on Bitcoin. And the route I want to do is basically Solana Sol to swap to USDC. Yeah, on Solana. CCTP that to USDC on Noble with Osmosis. Buy Bitcoin on Osmosis. Withdraw the Bitcoin to Bitcoin chain. Okay, that's a lot of steps. And unfortunately, we can't really get that all into one transaction right now. Some things you could do with all the smart contracts. This flow I just laid out, we couldn't even if we wanted to,
Right.
because there is not a way to do this CCTP bridge with metadata into Noble. Okay, So this flow would need at least uh, needs at least two transactions, but maybe three or four if that's smart contracts. Well, okay, as a user, I don't want to just be having sitting there like signing stuff, especially if you use Ledger, right, for bigger amounts. So what do we do? We make an NPC runner on your behalf, or an NPC account on your behalf that we call a runner. It's controlled by your existing wallet or a JavaScript key that's made in your browser or your phone. Oh, right then. You send your funds to that runner, and the signature you do to send funds in gives instructions that lay out what the runner is allowed to do. Like, hey, you're allowed to do a swap in Solana with ending up at this much USDC. You're allowed to bridge this to Cosmos or to Noble. You're allowed to sign something on Noble that will go to Osmosis, do a swap, and go to Bitcoin. But this is one user signature. There's only one thing to scroll through in your ledger, and then that's it. So how does this work? You send funds with this instruction to the runner. Then the runner talks to our backend for basically or the runner this lit the lit committee. He talks to the backend we run for okay, my funds are on I have this like soul on Solana. I want to go to USDC. How do I do it? Okay, backend gives the message. The runner signs it, validates some stuff, then signs it, and then broadcasts. Waits for it to get in. Okay, next step is go to Noble. Let's do that. Uh, and so the runner there is kind of this trustless thing that uh, that follows the steps the user outlined, but the user so it basically converts the user's intent with one signature or to many on-chain actions.
Very powerful. And then in this
Yeah,
system, presumably you're just like using the local liquidity on any given chain across the steps.
yeah, exactly. And then we designed the thing to try to use the best liquidity, or yeah, there's like this liquidity latency trade off. So if things are like liquid enough, do the fastest route. If there's a very big difference in price, then go take some time silver again.
Makes sense.
Okay, then.
Well,
Yeah,
Dave, this rules. Yeah,
thanks.
it's been super fun collaborating with your team. We got to hang out with a bunch of folks like a month and a half ago at our offices in San Francisco, and some pretty remarkable things have been built, but like still so much to go. I am extremely excited for Z wallets and shielded wallets on Polaris. It's going to be pretty epic.
Thanks.
Yeah. Anything else you want to add?
No, it's been great collabing, and excited to start keep on delivering this.
Awesome. Well, thanks for tuning in, everybody, and thanks, Dave.
Thanks all. Thanks, Dave, as well. Bye.